They want us to graph the following showing 2 points. So this is an exponential function. So I'm going to show 2 points. So I'm going to make an xy table, and again, y is 3 to the x plus 1 minus 2. That x plus 1's up in the power zone. How do I know what x values to put in? You can put in any x values you want. Like you could put in 0. That's a nice easy number. I'm just choosing 0 because it's easy. What do I get then? Y will equal 3 to the 0 plus 1 minus 2. And that's 3 to the 1 minus 2. And 3 to the 1 is just 3. 3 minus 2 is 1. So that's over 0 up 1. There's that point. Next, I'm going to plug in x is 1. When x is 1, y equals 3 to the 1 plus 1 minus 2. That's 3 to the second minus 2. 3 to the second is 9. 9 minus 2 is 7. So that's over 1. Oh, I'm sorry, I did this other point wrong, didn't I? It was over 0 up 1 right there. And this next one is over 1 up 7. So over 1 up 1, 2, 3, 4, 5. 6, 7. So over 1 up 7 would be way up there. So that's going to be off my graph. It's true, that's really a point, but because that's going to be off my graph and it's going to be too hard, it's going to really be a true point. It is going to go up, 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 up like this. It's off my graph, so I need to find another point that I can put on the graph that fits in the area they gave me. So instead, let's go backwards 1. We'll do negative 1. Again, I'm just doing that because I'm going to go back here to negative 1, and I hope it looks like it's coming down to the left, so it'll fit. So let me plug in negative 1 now. 3 to the negative 1 plus 1 minus 2. That's 3 to the 0 minus 2. Now, what is 3 to the 0? Remember, anything to the 0 power, remember what it is? It's 1, huh? Anything to the 0 power is 1, so that's negative 1. So that's negative 1, negative 1. So that would be right here. Point, negative 1, negative 1. So there's the graph. And so there's 2 points. When you use the graph making tool, you just need 2 dots. The rest of the graph comes back like this. You might have remembered from earlier in this chapter, we learned that the number out here, added or subtracted off to the right, is the horizontal asymptote for an exponential function. So it makes sense. Down here, this is negative 1, negative 2. At negative 2, there's going to be a horizontal asymptote. Now, you don't have to put that dotted line on your graph. I'm just letting you know it is there. It's going to flatten out. The graph will do it automatically for you when you just put these 2 points on the graph. Now, the second part of this question is they want me to graph that logarithm. Now notice it's very, very similar. In fact, it's the inverse function. See how this is 3 as the base, x plus 1 is the power minus 2. This is 3 as the base, x minus 1, the opposite of x plus 1, and plus 2 out there. Looks like the inverse function. Let's make an xy chart again. Okay, so can I put in like 0 for x? Can I put in a 0 there? No, that's not going to work. I'll let you try it on your own calculator. That'd be the log of 0 minus 1, which is the log of negative 1. If you do the log of negative 1 on your calculator, why don't you try that real quick? You'll get an error. The inside of a log cannot be 0 and it cannot be negative. So that's no. And if you did 1, that's not going to work either when you try to plug in 1, because then you would have the log of 1 minus 1, right? If you plugged in 1 for x, which should be a log of 0. Whoops, it's supposed to be a 0 there. Which is also an error. So that's a no as well. Again, the inside of a log cannot be 0 and cannot be negative. In fact, you might remember that that number that's in the parenthesis next to x, the opposite is what? Is the vertical asymptote. The opposite is the vertical asymptote. So that means x equals positive 1, right there, at positive 1. That's going to be the vertical asymptote for a log graph. A log graph always has a vertical asymptote, and back over here, an exponential graph has a horizontal asymptote. So that's why that agrees with the fact that you can't make the inside 0. It doesn't exist there. It can't touch that vertical asymptote. So you can't be at x equals 1. That's why it's a no. So we'll have to start at 2. So let's plug in 2 now. So we have log base 3. These should have all been log base 3, but I was just ignoring it. 2 minus 1 plus 2. That's what y will equal. Now that's log base 3 of 1 plus 2. Now, how do you figure out on your calculator a log base 3? You don't have a log base 3 button. You just have a regular log button, and you also have a natural log button. So how are we going to do log base 3? Well, here's a trick for doing log base 3. You need to make this into 2 logs. So it becomes log 1 over log 3, and then the plus 2 is still out there. That's how we do it. So I changed this 1 log into 2 logs, and the part that's lower down, the 3, he's the base. See how he's low down at the bottom of the G? He goes to the bottom of the fraction. So the bottom, the low part goes low, the higher part, the 1, stays high, and the 3 goes low. And you make it 2 logs. Now, I haven't given a reason for that, a logical reason. Let me write the formula. Log base, well, let's write it this way. Log base b of a is log of a over log of b. That's changing the log, I should write it on the top, changing the log base. That's how you change the log base. What do I mean change the log base? Well, here the base is b. What's the base on this log and the bottom log? There's no base showing. So the base must be 10 for both of those logs. Remember, when the base is invisible, it's really 10 for the normal log word. If you write L in, that base is an invisible E. But if you write the normal log word, the base is an invisible 10. So we just changed the base. We changed it from a base of B to 2 logs that have an invisible base of 10. So that property, it can be proven. I'm not going to prove it right now, but we use it whenever we have a weird log base. It's like over here we have log base 3. We don't have a log base 3 button on our calculator, so we change it to just a normal log of 1 over a normal log of 3. Both of those are base 10 logs because there's no base showing. So hit the buttons on your calculator now, and what you'll get is 0 plus 2, 2. So now we've got a point over 2 up 2, right there, over 2 up 2. Now what should we plug in for our next point? Should we just go up by 1 to like 3? No, that's not going to work, but let me show you. Let me show you why. Y equals log base 3 of x minus 1 plus 2. So if you plug in that 3 right here, you'll get log base 3 of 2 plus 1. And remember, again, that's a weird log. What do? We let the higher part go higher and the base, the lower part, go to the bottom, like that. And then if you hit the buttons on your calculator, I'll do it now too, we're going to get some decimal that's not a clean whole number. I'm getting, and then you add the 2, so it's coming out 0.63, it goes on and on, plus 2, and I'll just round it to 2.6. Now, 2.6 is not on my graph. Over 3, here's 2, here's 3, up 2, let's see, 1, 2, 3, up 2.6, it's about right there. But I can't put that on the graph with any precision, so it's not really a point I can use to put on the graph. Well, I should do this in a smart way. What kind of point should I pick? Well, you want to plug something into the log right here that'll eventually match the 3. So let's plug in 4, because 4 minus 1 will be 3, and that'll match the base, and that'll make the answer come out nice. Let's see it. So if we plug in 4, I'll do it over here, kind of, well, maybe I could just do it right here. So I'll plug in 4 now, and I get log base 3 of 4 minus 1. I'm supposed to say y equals there. So y equals log base 3 of 4 minus 1 plus 2. And that's going to come out log base 3 of 3 plus 2. So remember what we do when we have a weird base. We make it into a fraction. The higher one goes in the top and the base goes to the bottom. And I don't really need a calculator to tell me what that is. This is the same thing over top. This is 1. See why that made it easy? So you plug in a number that will make the inside, plugged in 4, so 4 minus 1 is 3, and it matches the base, and then this comes out just a nice clean 3. You get a nice whole number answer that way. Don't even have to use your calculator. So that's the point. Over 4, up 3. Right here, I could have left that other point. I guess I didn't need to erase it. It was right there. So, but this is the point we'll actually use. Over 4 up 3 right here, and then the one right here at 2, 2. So click those 2 dots on the graph maker, and it'll produce that logarithmic graph right there. So log graphs are always like a bowl turned down. We call that concave down. It's like a bowl turned down. And exponential graphs are always concave up. They're like a bowl turned up. They launch upward very fast and then flatten out, whereas logarithm graphs are concave down and they go straight down. They take a dive on the other side, and then they're concave down like a bowl turned down. So we just need the 2 points. You don't have to graph the asymptote line that I graphed. Just put the 2 dots, and that'll be good enough.